Today we will conduct a test on active and reactive power control of an alternator. Now in our power system lab there is an alternator of around 3 kVA which is coupled with a DC shunt motor. Okay, now this is the nameplate of our alternator. Its voltage is 410 volt, synchronous speed is 1500 rpm, rated current is 1.75. Now in this circuit diagram, this is our alternator and this is coupled with a DC shunt generator, and there is an arrangement for giving power to an induction motor along with a mechanical loading arrangement. Now before we conduct the test, we have to first find out one important parameter, that is synchronous impedance. For that we have to conduct two different tests. One is the short circuit test, where this alternator is run at its synchronous speed, that is 1500 rpm, and its output is being shorted with the help of ammeter. Now the excitation current is being increased to some value when 120% of the rated current will flow through the short circuit. So it is 2.1 ampere. So we have to adjust the DC field current, DC field of the excitation, so that 2.1 ampere current flows through the short circuit, and we have to note down this IA. Now open circuit test. The short circuit is removed. Now again the DC motor is run at the synchronous speed. Output is kept open, and the excitation current should be maintained at what we got earlier. For the same field current, we have to note down the line to line voltage. Now with very simple formula we can get the magnitude of the synchronous impedance. So that is the per phase one. That's why it is VOC divided by root G. Okay. Now its real part, which is the armature resistance, can be obtained just by measuring the armature resistance. But if I connect this multimeter in ohm mode, the two terminal will get the double of the winding resistance, because the machine winding is connected in star fashion. So when I am connecting a multimeter, the reading becomes the double of this. So the armature resistance will be just half of the reading, and from here we get the imaginary part of the impedance, that is XS, which is equal to root over of ZS square minus R square. So ultimately we are getting this parameter. Okay, it is required to find out the machine angle. Now let us go to the main circuit where a three-phase switch is there to supply or to connect the load along with a mechanical loading arrangement, and two wattmeter is connected to get active reactive power as well as power factor. So first, the same way the DC field to the DC motor is given, and the armature voltage is being controlled or adjusted to give its synchronous speed. Okay. Now this excitation voltage or current should be increased so that the terminal voltage becomes 410 volt. So at the rated value 1500 rpm or 50 hertz, and at the rated voltage this switch is made open, switch is made close, so that the motor will take small active power and reactive power. And when it takes active power, the speed will drop, and when it takes reactive power, the voltage will drop. And we have to adjust this input prime mover power to maintain its speed at 1500 rpm, and to maintain the voltage at 410 you have to adjust the excitation current. Okay, so in this way we can maintain its rated voltage and frequency. Okay. Now in the same way we can increase the mechanical load also to take more active and reactive power. So intentionally we will apply more mechanical power, so active and reactive power will be increased. So this voltage and the frequency or speed will again drop. So to maintain those values at their rated, we have to adjust this excitation and the armature voltage of the DC motor separately. So that is the test, and we have few relationship or the formula is the EMF equation. Here is the active power delivered by the alternator, is the reactive power delivered by the alternator, and these equations are required to find out the machine angle. What is machine angle? Machine angle is the angle between the induced EMF and the terminal voltage. Okay. And we have to fill out this table where this is the power delivered by the alternator, that is W1 plus W2, this reactive power, this power factor. So these three can be obtained from wattmeter readings, then field current, terminal voltage, load current, frequency, speed. Mechanical power is same as W1 plus W2 if we consider that there is no loss, and this has to be calculated machine angle, which is delta. So with the help of this previous formula. Now we have to take all these parameters for different condition. As I have said, first condition was the mechanical load was not there, only induction motor is connected, so small active and reactive power will be taken. So those values should be put here. So the voltage and the speed will not be the voltage, speed as well as the frequency. These three will not be at their rating. Now to maintain the voltage, speed at the rated, we have to adjust the field excitation and prime mover input, and we have to take all these parameter for this steady operation when voltage and frequency are at their rated. Then in the condition 3, we intentionally provide some mechanical load on the induction motor to increase the load current. So it will take more active and reactive power. Again, this voltage as well as the speed and frequency will drop. And to maintain again at their rated value, you have to adjust the field excitation and prime mover input. Okay, so you need to fill up this table carefully, and this delta has to be uh, found out. So that is the experiment.